हेलो एवरीवन, गुड इवनिंग। कैसे हो भाई? क्या हाल चाल? सो वेलकम अगेन टू दिस। हेलो एवरीवन, गुड इवनिंग। कैसे हो भाई? Welcome again on this amazing series of PK Nag unsolved questions. We are going to continue our discussion on. So we have covered what Zeroth law, work and heat transfer. Now we are going to move on first law of thermodynamics for closed system. Then we'll go to open system. Okay, so be with me if you really want to improve your score in thermodynamics, basic and applied. Okay, chalo. Before we start the session, quick announcements. So as you all know, these are my sessions for this month. From Monday I will take these sessions on app. These are our free app classes. And in order to attend these classes, good evening AP, good evening, you have to download the app. So just download the app by scanning this QR code or by clicking on this link. Okay. Also, I hope that you have all seen this schedule as well if you are in my Telegram group. So today we are having this session, and the next will be on Monday, first law for. Okay, this is first law for open system. Okay, and the next one is second law of thermodynamics that will take on YouTube. And the white sessions is 20, 21, 22, 27, 28, 29. These are on free app classes. Good evening, Anu. Voice echo is happening. Let me check, Baba. Hello, hello. Hello, hello. Is it better? Is it better now? No? Okay. Let me just check. Just 1 second. Abhi bhi? Still there? Still there? Now audible? Better? Chalo, ठीक है. Still there or better? Yes. Yes means problem is still there. Yeah, it's better. Chalo, let's. So guys, the white sessions you can see, these are for free app classes. So if you want to join these, already this schedule I have shared on my Telegram group. Okay, ठीक है, thank you. I have already shared this schedule on Telegram group, so you can go through it. In order to attend app classes, of course, you need to download the app. So you can also download the app by, below this YouTube session. There is a link that you can click and you can directly be directed to the app. So you have to download that and then you can attend our free classes. Okay, or you can scan this QR code as well, whatever you want to do. And guys, we are very soon starting our GATE 2025 and 26 batches. So if you are planning for GATE 2025 and 26, You can join these batches. You can find out more information by calling this number. And it is a very structured course. You have live classes, recorded lectures, study material, practice quiz and mock test as well. Good evening, Maniket. Chalo. So again, you have to download the app. So you can download by clicking on this link to attend these lectures. Okay. Chalo. I hope that you have downloaded, if you have joined the group. If you have not, join the Telegram group, because all my PPTs, all my schedule is shared in this Telegram group. More than 1100 members are there. I think more than 1100 members are there now. You can join by clicking, scanning this QR code, or just by searching Mechanical by Vipin Yadav. Okay. Chalo. Let's start the session. Let's start the session with a quick introduction. What is happening? बफर तो नहीं है यार, बफर तो नहीं है. चलो, तो I have 6+ years of teaching experience. I have taught for GATE, ESC, AE, JE and other PSUs as well. I have done my MTech from IIT Kharagpur. I have done my MSc from Politecnico di Milano in Italy. 3.5 years of industry and research experience. I have few research publications and my area of expertise is basic and applied thermodynamics and heat transfer. ठीक है, चलो स्टार्ट करते हैं विद फर्स्ट क्वेश्चन. फर्स्ट क्वेश्चन, वेरी फर्स्ट क्वेश्चन क्या कहता है? An engine is tested by the means of water brake at 1000 RPM. No, buffering is not there. I can watch that. Okay, buffering is not there. Just refresh your browser. Okay, chalo. So N is equals to 1000 RPM. And the measured torque is 10,000 Newton meter. And the water consumption of the brake is this. So volume flow rate is 0.5 meter cube per second. Its inlet temperature being 20 degree. Inlet temperature is 20 degree. Calculate the water temperature at exit. Assuming that the whole of the engine power is utilized, is ultimately transformed into heat, which is absorbed by cooling water. That means your engine is running and you are storing. You want to stop the engine by giving a water supply. Your engine is running at 1000 RPM and you want to apply water. So when water stops it, so energy will be generated and that energy will be stored. Okay, by the water. So water temperature is increasing from Ti to Te. So how much energy, what will be the temperature, exit temperature? So you see, by whatever power, if the engine is rotating at 1000 RPM, so what will be the power? So power released by engine or engine power will be directly generated or transformed into heat absorbed by water. It is saying कि engine power is equals to heat absorbed by water. So tell me, what is engine power? Torque into omega. What is heat absorbed? MC dt. Now torque is 10,000 RPM. This is 2 pi n by 60. Mass is what? Density into volume flow rate into specific heat is 4.18 into T exit minus Ti. What is this value, Baba? अच्छा टॉर्क इंजन पावर, ठीक है कोई नहीं, कैलकुलेट कर लो. सो नाउ आई कैन से 10,000 into 2 pi n by 60. Density of water is what? 1000. Volume flow rate is what? 0.5 into 4.18 plus Ti. Ti is 20 degree, means 293 is equals to T exit. So you can find out this. T exit is how much? Very little increase you will see, very little increase. 10,000 into 2 pi by 60 into 0.5 into 4.18. कितना आ रहा है? थोड़ा ज्यादा आ रहा होगा, हल्का ज्यादा आ रहा होगा, ठीक है. कितना आएगा? This I need to take in joule, okay, because this I have taken in Newton, okay. So you'll get 0.501 plus 293. So it is 293.501 Kelvin. This we have taken in Newton meter. So this I need to take in joule. Okay, understood? Chalo, next question. A slow chemical reaction takes place in a fluid at constant pressure of 0.1 megapascal. That means pressure remains same, 0.1 megapascal. The fluid is surrounded by a perfect heat insulator, during which the reaction will begin at state 1 and ends at state 2. The insulation is then removed and 105 kilojoule of heat flow to the surrounding as the fluid goes to stage 3. तो state 1 to 2 क्या हो रहा है? No heat transfer, Q is equals to 0, insulated है. But when you are going from 2 to 3, heat rejection is happening, यानी कि 105 kilojoule of heat is going out. The following data is observed from 1 to 3. For the fluid system, calculate E2, E3 if E1 is 0. I have to find out E3 and E2. So, I know one thing. First law of thermodynamics for a process. What is it? dq is equals to du, but it is here de plus dw. Now, by let us say Q122 is equals to E2 minus E1. And work is at constant pressure means what? PV2 minus V1. When I am going from 1 to 2, then I am saying this, okay. So this is 0. E2 I need to find out. E1 is 0. plus pressure is 0.1 into 10 to the power 5 upon 0.3 minus 0.003. Tell me how much is E2? How much will be E2? Calculate E2 quickly. Now once E2 is calculated, then you can do Q223 is equals to E3 minus E2 plus work. So P V3 minus V2. Now this is minus 105. Heat is rejected. E3 I need to find out. Tell me what is E2? Plus 0.1 into 10 to the power 5. 0.06 minus 0.3. कितना आ रहा है E2? E2 आएगा -29.7. So when you put it, it will be plus 29.7. Now tell me how much is E3? E3. बहुत दिक्कत है मनी के तुम्हारी कैलकुलेशंस में, ध्यान रखो इस बात का, वरना ये हर्जाना भुगतना पड़ेगा. So this is what? Kilojoule. ओके, हेयर 6 है, ये मेगा पास्कल है ना, तो 6 आएगा यहां पे, ठीक है. और जब 6 आएगा तो किलो जूल में आपको ये मिल जाएगा, ठीक है. अब E3 बता दो, E3 किलो जूल में, किलो जो मिलेगा यहां पे वो क्या मिलेगा? जूल में. उसे किलो जूल में कन्वर्ट करना है तो कितना आएगा? -110 किलो जूल, ठीक है. कैलकुलेट, जो मिलेगा जूल में मिलेगा उसे किलो जूल में कन्वर्ट करना है, ध्यान रखना उसे. ठीक है, चलो नेक्स्ट क्वेश्चन. द प्रॉपर्टीज ऑफ अ सर्टेन फ्लूइड आर एज फॉलोज. यू ये है, पीवी ये है, वेयर यू इज स्पेसिफिक इंटरनल एनर्जी and T is in degree Celsius, P is in pressure, V is in specific volume, meter cube per kg. CV and CP I need to find out, CP and CP. So first of all, CV is equals to, क्या पढ़ा है हमने? CV क्या होता है? du by dt at constant volume. यानी कि d by dt 196 plus 0.718 t. Okay, D by temperature. So what you are going to get here? 0 plus 0.718, and therefore it is 0.718 kilojoule per kg Kelvin. Next is Cp. So Cp is what? Cp is d by dt of dH at constant pressure. So it equals to d by dt. H is what? U plus PV. So d by dt. U is what? 196 plus 0.718t. PV is what? 0.287 t plus 273. So if I differentiate this, it will be 0 plus 0.718 plus 0.287 plus 0. So it is 1.005 kilojoule per kg Kelvin is Cp. This is what they are asking simply. ठीक है. Now next. A stationary system consisting of 2 kg of fluid from the last question. The last question is Cp is equals to 1.005, Cv is equals to 0.718 kilojoule per kg Kelvin. Expands in a adiabatic process. कैसा process है? Adiabatic. According to PV 1.2 is equals to constant. The initial condition are यानी कि P1 is 1 megapascal, T1 is 200 degrees Celsius, P2 is 0.1 megapascal. Find W and delta U. So first thing, it is a adiabatic process. So if it is adiabatic process, I know dq is equals to du plus dw. अब एडियाबैटिक है तो दिस इज जीरो, सो dw इज इक्वल्स टू माइनस du माइनस cv dt mcv dt. mcv dt. The point is, it is cv I have already taken. I need to change this from T1 to T2. Now what is T2? T2 is not given, but I know it is adiabatic. I know it is adiabatic. So can I say T2 by T1 is equals to P2 by P1 gamma minus 1 by gamma. So T2 is equals to T1 is how much? 200. Better to always convert into Kelvin, okay? So 473 into 0.1 by 1. Gamma is 1.4. Gamma is 1.4. How will you get gamma 1.4? Because you see the ratio of this. It is 1.4. Cp by Cv, okay? So 0.4 by 1.4. And you will get how much? In fact, this is given to you. 1.2, it is given 1.2 basically, okay? Not 1.4. जीरो पॉइंट टू बाई 1.2 कितना आएगा T2? हाउ मच इज T2? It is 0.1 to the power 0.2 by 1.2 into 473, 322 Kelvin, 322 Kelvin. So your T1 is this, T2 is 322 Kelvin. T1 is 473 Kelvin. So now minus 2 into CV was 0.718. 0.718, 473 माइनस 322 कितना आएगा? ये वर्क कितना आएगा? हाउ मच इज वर्क? माइनस, यस, माइनस भूल गए क्या? और डी कितना है? 216 किलो जूल. ठीक है, चलो नेक्स्ट. Now, the heat capacity at constant pressure of a certain system is a function of temperature. Cp is given, where T is the temperature of the system in degrees Celsius. The system is heated while it maintained at constant pressure of 1 atmosphere until its volume. So, pressure remains fixed at 1 atmosphere. While volume increases, V1 कितना है? 2000 centimeter cube. V2 is 2400 centimeter cube. And temperature T1 is 273 Kelvin to 373 Kelvin. Find the magnitude of heat interaction. How much does the internal energy of the system increase? चलो, कांस्टेंट प्रेशर प्रोसेस है, कांस्टेंट प्रेशर. सो हीट ट्रांसफर इन कांस्टेंट प्रेशर इज इक्वल्स टू DH इज इक्वल्स टू CP dt इंटीग्रेशन ऑफ T1 टू T2. तो CP is given 2.093, 41.87, T plus 100, T1 to T2 dt. This term is capital T basically. Here I think one plus is missing. Okay, chalo. 2.093. When I integrate it, I will get T here plus 41.87 ln T plus 100 ln T plus 100. ठीक है, ठीक है, डिवाइडेड बाई 100 बिकॉज t you have to divide by derivative of t plus 100. ठीक है, and t1 to t2 you need to do, so you will directly write t2 minus t1 plus 0.4187 ln t2 plus 100 by t1 plus 100. Quickly tell me what is heat transfer. Quickly tell me what is heat transfer. Okay, there is slight problem here. This temperature is given in degree Celsius. यानी कि T is given in degree Celsius. But these temperatures are in Kelvin, so I cannot use directly. One second. I cannot use them directly, okay? So what will I do? I will convert this into Kelvin. So T plus 100. T plus 100. Either I can convert this or I can take this into degree Celsius, whatever I want. So let's take this into degree Celsius, okay? So put this into degree Celsius simply. 0 and 100. You can do either of the things. Or you can convert this temperature plus 273 is equals to temperature in Kelvin. Okay. So this is degree Celsius. This is in Kelvin. So T is equals to T minus 273. Either I can do this. कितना आ रहा है आंसर? कितना आएगा? Calculate quickly. कितना आ रहा है? By this is what? 100 minus 0. So this is 209.3 plus 0.1487 ln. T2 is what? T2 is what? T2 is 100. So it is 200 by 100. So quickly calculate. Why are you not able to calculate this? यस, तो 209.58 ठीक है. Now internal energy change, I need to calculate internal energy change. So bhaiya dq is equals to du plus dw. I need to find out du is equals to dq minus dw. This is 209.58 minus dw कितना है dw pdv, दोनों चीज पता है मुझे. प्रेशर कितना दिया हुआ है 1 एटमॉस्फेयर यानी कि 101.325 किलो पास्कल इंटू 2400 माइनस 2000 यानी कि 400. So you can calculate this. But mind it is given in centimeters cube. Centimeter cube. So you have to convert this into meter cube. Okay. You have to convert this into meter cube. Quickly tell me what is the answer. Somewhat I think so, yeah. कितना आ रहा है इतना कैसे आ रहा है 0.0024002. ओके सेंटीमीटर क्यूब है ना ये, तो 6 आएगा यहाँ पे. इट इज सेंटीमीटर क्यूब नॉट स्क्वायर. ओके तो ये आएगा 400 इंटू 10 टू दावर -6 इंटू 101.325 209.58 माइनस आंसर. कितना आया ये this kilojoule. This is joule, sorry, joule. And this will also be, now this is joule, so this should also be in kilopascal. It is in pascal, it is in meter cube. Okay, so this will be 209.58 minus 101.325 into 10 to the power 3 into 0. Now you will get something, whatever you will get in joules. Whatever you are going to get, you will get in joules. 101.325 into 10 to the power 3 into 400 into 10 to the power -6. 209.58 minus this is कितना आ गया 169.05 joules du. ठीक है, माइनस करो भैया, माइनस करो. प्लस कर रहे हो क्या? 197 क्यों आएगा? चलो नेक्स्ट. An imaginary engine receives heat and does work on a slowly moving piston such that rates that the cycle of operation of 1 kg of working fluid can be represented as a circle of 10 centimeter in dia on PV diagram. That means my cycle can be shown on PV diagram as a circle with a dia of 10 centimeter and where 1 centimeter is equals to 300 kilopascal, or you can say 0.1 meter cube per kg. I need to find out work done by each kg, यानी कि 1 kg of working fluid for each cycle of operation. Then thermal efficiency of the engine is defined as the ratio of work done and heat input in a cycle. If heat rejected by the engine is 1000 kilojoule per kg of working fluid, what will be its thermal efficiency? Very simple question, very simple question. Okay, चलो पहले तो I need to understand this कि if I need to find out work, then work is given by area enclosed by the cycle on PV diagram. So area of circle क्या होगा? एरिया ऑफ सर्कल क्या होगा? आपको डायमीटर पता है π/4d², है ना? तो π/4d², ये क्या दे रहा है मुझे? एरिया π/4d², लेकिन ये है किसमें? इट इज इन सेंटीमीटर स्क्वायर, ठीक है? 10 सेंटीमीटर, तो 10 स्क्वायर इंटू 10 स्क्वायर इंटू π/4, 78. But I want work. It is work doesn't have a unit of centimeter square. So I need work. How will I be able to convert this into work? So work is equals to this area. It is in centimeter square into 300 kilopascal per centimeter into 0.1 meter cube per kg. Just 1 second guys, something happened. Per kg, ठीक है? Per kg. So, by I need to convert this into joule or kilojoule, whatever units I have. Okay. Now, so centimeter square, this will get cancelled. This 78.53 into 300 kilopascal means kilonewton per meter square into 0.1 meter cube. So it is kilonewton meter means kilojoule. क्या आएगा आंसर? टू थ्री फाइव सिक्स किलो जूल. आ रहा है इतना? इज इट कमिंग? Yes. Then they are asking thermal efficiency. So what is thermal efficiency? Is equals to net work by heat input. Now heat input is not given, but can I write Q in? Whatever heat you are supplying, it will be converted to either work or rejected. So I can supply Q W net plus Q rejected. I know everything. 2356 upon 2356 plus 1000. So you can find out thermal efficiency. कितनी आ रही thermal efficiency? कितनी आ रही है thermal efficiency? $197 क्यों आ रहा है अभी देखेंगे, अभी थोड़ी देर में देखेंगे, ठीक है? 70%, ठीक है? ये 197 कैसे आ रहा है भैया, ये बताओ तुम. ये आएगा 40. आर यू एबल टू कैलकुलेट दिस एज 40 और नॉट? टेल मी फर्स्ट ऑफ ऑल. आई हैव कैलकुलेटेड इट जस्ट नाउ. समथिंग अराउंड 40 यू आर गेटिंग. And if you get this for T, you minus 40 from 209, so you will get this 101.325 into 10 to the power 3 into 400 into 10 to the power minus 6, 40.53 exactly. Okay, so just recheck it, maybe recheck this later. Okay, chalo, this is your last question, and then I mean second last question, and last question you will get for homework. Okay, चलो ये बात देखते हैं. A gas undergoes a thermodynamic cycle consisting of three processes beginning at the initial state where P1 is equals to 1 bar, V1 is equals to 1.5 meter cube, and U1 is equals to 512 kilojoule. Now 1 to 2 is compression with PV is equals to constant, यानी कि 1 to 2 is isothermal. Okay, तो P2 increases to 2 bar, and U2 P is equals to constant. Okay, I think there is some issue with this equation. It should not be P is equals to constant, otherwise you should not change. Okay, so maybe there is some issue with the equation that I have taken from book. Okay, here. So if you have taken temperature in Kelvin, then I will need to check. There is maybe some issue with the equation then. Okay, I will recheck it. I will share the solution in the Telegram group. Okay, some issue then with the equation could be. Okay, chalo, let's finish the last question first of all. Now, it cannot be PV is equals to constant because I have taken it from PK Nag. There could be some issue because if yes, could be. I'll check that. Okay, no issues. Now, so look, it cannot be PV is equals to constant because PV is equals to constant means isothermal. And if it is isothermal, then du must be 0. So U1 cannot be equal to U2. So there is some mistake maybe here. Okay. But anyway, but here U2 is equals to 690 kilojoule. Okay. And I need to find out Q12 and Q31. So if I talk about 1 to 2 process, can I say dq 1 to 2 is equals to du 1 to 2 plus dw 1 to 2? dw 1 to 2, ठीक है, चलो. So now I need to find out dq 1 to 2, and du will be u2 minus u1 plus अब there is a question here. Should I take it isothermal? Should I take it polytropic? If I take polytropic, I need to know n. Okay, so either something is missing here. क्या है 150? What is 150 बाबा? Heat transfer. Wait. Okay. So I don't know if I should take isothermal or polytropic. If I need polytropic, I need n. So for one instant, because we need to know the concept, that's all. For one instant, let us assume it is isothermal, okay? So if it is isothermal, then I can take P1 V1 ln V2 by V1, or I can also write, because V2 and V1 is V2 is not known, so I can write P1 by P2. And you know everything, 690 minus 512 plus P1. P1 is 10 to the power 5. Square into V1 is 1.5 and this is 2. One by 2. So you can find out Q122. कितना आ रहा है? 74. यस 74 आ गया, बिल्कुल सही. Now Q122, I got Q122. Now I need to find out Q321. Q321. So Q321 is equals to U3 minus U1 plus W321. Now U3 is not known to me. U1 is known to me, which is 512 plus W31 is 50. So the only thing I need is U3. How can I find out U3? How can I find out U3? From process 2 to 3. Again, Q2 to 3 is equals to U3 minus U2. Okay. It is 3 to 1, right? It is 3 to 1. So I should write, if I am going from 3 to 1, so 1 minus 3. This is 512 minus U3. Okay. Chalo. U3 minus U2 plus W223. Now W223 is given is 0. Q223 is 150. Is equals to U3. U3 is, I have to find out. U2 is given to me 690. So you can find out U3 is equals to minus 50 plus 690. कितना आएगा U3? How much is U3? 540. Yes, it is 540. So write 540 here. Plus 50. How much is Q? $31 आ रहा है क्या? 512 minus 540 प्लस 50. 22 आ रहा है भैया. 31 कैसे आ गया? ये 28 आएगा ना, माइनस 28 प्लस 50. 22 आ रहा है. 22 किलो जूल आएगा. यस और नो? आ रहा है ना? अच्छा 22 आ रहा है. ठीक है ठीक है, देखा नहीं मैंने. Q31. ठीक है चलो. Similar question you can get this one as well. Similar question you can get this as well. Okay. So first of all, process 1 to 2 is given. Process 2 to 3 is given. And process 3 to 1 is given. Okay. Constant pressure. Compression with isothermal compression and constant volume. हाँ ठीक है ठीक है ठीक है, चलो समझ गया मैं. ठीक है, एक तो बहुत कम टेक्स्ट दिखता है यहां से. ठीक है चलो. तो पहले स्केच करना है पीवी डायग्राम पे, फिर नेटवर्क निकालना है, नेट हीट निकालनी है और ये प्रूव करना है. ये प्रूव करना है जब सारी वैल्यूज आ जाएंगी तो. ठीक है, तो हर प्रोसेस का हीट ट्रांसफर वर्क ट्रांसफर निकाल के उन्हें इक्वल रख के देखना है कि ये सेटिस्फाई कर रहा है या नहीं। कर रहा है तो बहुत बढ़िया, ठीक है। तो ये क्वेश्चन एक बार होमवर्क में देख लेना, ठीक है। बाकी जो एक क्वेश्चन बचता है वो मैं एक बार देख लूंगा क्या दिक्कत आ रही है उसमें। मेरे ख्याल से इंटीग्रेशन में दिक्कत है शायद, या फिर टेम्परेचर में दिक्कत है, ठीक है। तो एक बार मैं देख लूंगा उसे, ठीक है। चलो, तो यहां पे स्टॉप करते हैं, लास्ट क्वेश्चन था ये। एंड गाइस 22 नवंबर को राकेश सर conquer gate 2025. If you are planning for gate 2025, then you can attend this session. Also 19th November, which is day after tomorrow, Sunday, you have a scholarship test. If you want to join batches for gate 2025 or 26, then you can go for a scholarship test. You can avail up to 90% of scholarships, ठीक है। चलो स्टॉप करते हैं यहाँ पे, ठीक है गाइज। एंड आई विल मीट यू वेरी सून। tomorrow I don't have a session. Monday I have a session. Monday we have PK Nag unsolved question, first law for open systems. First law for open systems. So do not forget to attend the session Monday 20th 9 p.m. only, ठीक है। चलो, very good. Thank you guys. Thank you. I'll see you on Monday. Thank you. Thank you. Thank you. Bye.